We'll just take another 20 seconds or so to fill this out. In the meantime, I'd like to talk about solid waste management here. It's a topic that Rebecca and I get a lot of calls and emails about, especially over the last couple of years. This is due in part to the grant money and lending options that are out right now that are available to small processors that want to update their waste management options. But truly, the root cause of these discussions coming up so often revolve around the fact that the traditional methods of waste removal solutions are becoming less and less. Environmental groups and local state governments have become more interested in how small processors are handling wastes, and more oversight to open air composting has come around. My personal experience is that in California, it's not permitted at all for meat processors, at least. Local rendering companies have been acquired by or outcompeted by large national renderers, and those very same national companies have eliminated many routes, tightened requirements, and increased fees for the ones that are still in operation. Additionally, line landfills have significantly raised their rates per load, and many are refusing to take slaughter viscera at all anymore, aside from small amounts of specified risk materials, or SRMs. Services to haul waste to line landfills aren't cheap either, as we know, as we're seeing in the poll here. Services to haul waste to line landfills have gone up significantly, 30 to 40% in the last 2 years. Some plants that I've talked to in the last 30 days have been reporting $1,100 or more per run to the dump, and that's for a single gooseneck trailer. Some plants are taking double trailer loads up to twice a week. So we're talking, a very significant expense on the P&L. So not only is this an issue of cost and space, but many of NMPAN's community are deeply invested in regenerative and sustainable practices, right? So the landfill simply isn't meeting that criteria. So people have been asking us, how do we turn this waste material into something we can put back into the environment, or even potentially a revenue stream? So now that we're done with the poll, thanks everybody for filling that out. I'd like to introduce our two expert organizations today. We've got Beau and Alistair Haughton of Assured Renewables. Hey fellas, thanks for joining us this morning. And then they're going to talk for 20 to 25 minutes, and then we're going to move into Matthew Epp from Ecodrum. Hey Matthew. And I'm David Darling, Program Manager again for NMPAN, and please pop all of your questions in the Q&A as we go, and then we will address those at the very end. So without further ado, Beau and Alistair, take it away.
Yeah, thanks, David and Rebecca and the whole NMPAN crew. We just appreciate being included on this. I'll let Alistair take over here in a second, but just briefly, I come from the meat processing side of things, and everything that David outlined as challenges for the rendering side, especially small communities. All those challenges, led us to kind of partner with Assured Renewables. And then I also work for Wastewater Panels, WWP. And so connecting the technology of being able to do rendering on site to the meat processors is just a really exciting thing for me. But, Alistair, he's the expert. He'll tell you more about it. But again, seeing some of the people that are here on the webinar, it's been exciting to talk to them about their challenges, and then also try to come up with some solutions for that. So we appreciate you including us.
Thank you. Thanks, Beau. Thanks everybody for having us. Again, Alistair Haughton. I'm with Assured Renewables, a Canadian company originally, and we're now into the United States and of course Europe. We started around 25 years ago. We developed up technology, patented it specifically for the US military forward operating bases to manage black bag, all solid waste generated by the military without having to do burn pits. We deployed that tech from basically all corners of the earth and continue to deploy it to the military and some civilian clients. From there, we moved into the organic sector, specifically following the EU model that they were closing all landfills and basically source separating or separating at the areas that were generating the waste. We determined quickly that there was a market of space available in terms of outside of anaerobic digestion. And just as a side note, we have built, own, and still operate 18 anaerobic digesters in Europe, specifically the dairy farm level, where we take the manure, as well as silage. From there, we moved into something following our example for the military. We needed it to be modular, scalable, very robust, as we call it, mission critical unit, but simplistic enough that a simple couple of hours training with an operator would allow them to operate the unit without having to have, a 4-year education program. In essence, what we did is we followed the same pathway as Mother Nature. Stick your hand into, which is interesting, Matthew and I were just talking about a fire that's set off just north of us here in Port McNeill in a wood chip pile. So as you know, if you put your hand inside of a compost pile in your garden, and it could be winter, it's still quite warm inside. Summer, of course, gets a lot hotter. That heat that you're feeling inside is a thermophilic action, which is the highest level of, simply put, bug activity. And what's happening there is they're just working very hard, and they're loving it. And they're breaking down the materials at a very, very fast rate within the pile. So we took that thermophilic action and applied it in the machine sense. And the engineering pathway is very simple. Keep a constant temperature of around 160 degrees, aerate the material, allow natural air to flow over to feed the bugs because they're aerobic bugs, and then continually follow that process. And during that process, we of course don't introduce water. We don't put water out. We have a small amount of steam that comes off the system, which is just a byproduct of the heat in the unit. And on average, in 24 hours, we are able to produce a high-grade compost that is safe to handle. And it actually meets what they call the PAS 100 standard, which is the European standard for composting, and that's safe to handle by a human being. Because we're at 160 on average, we're able to eliminate basically all pathogens, viral vectors, and the like, thus making it even safer for both human as well as, of course, animals. So we're not in a position where we're producing a product that we're just transmitting other problems to other areas. If we're dealing with specifically organics, let's say, for instance, tomatoes, cucumbers, and the like, you're going to have around 70% reduction, maybe a little bit more, because you're dealing with a high volume of moisture. When it comes to organic product, for instance, from offal, we're seeing a lot less of moisture removal, and we're seeing a greater output in terms of the volume. So we're getting around 70 to 75% output. So we're losing a smaller amount of moisture, but that's because of the trim and the like doesn't contain a lot of moisture. There is blood, of course, in there. Now, the benefits is that you end up with a very concentrated compost material, which you're then able to use in a more, let's say you can cut it easier because it's going to burn. So what ends up happening is that in, say, for instance, my latitude, we'd use maybe 1 part to every 10 parts soil. In Beau's latitude, Wyoming, it's a lot drier. The soil isn't as rich or nutrified, so you're using a higher mixture for native soil. Now, again, a simple process that we follow is very similar to Matthew's process. All the material coming off of the kill floor or the inedible room flows into a pre-shred. So we're reducing the volume into a more homogenized state. And usually it's in about a 1 inch to 2 inch size. That's particularly on the bones. The rest of the materials, of course, shredded down to a much smaller diameter. We now have a homogenized waste. It's then fed to the digester. And as I mentioned before, we're not having any other inputs. The system can be fed continuously. It's not a batch system. So every time there's offal, it just gets fed in. 24 hours later, it's already producing a high-grade compost, and then of course expelling it from the unit. As I'd mentioned before, they are modular and scalable, so we have sizes that are everything from 250 kilo a day up to multiple tons per day. If you're in that range where you're, above sort of 20, 30 tons a day, then we of course would recommend going to something more robust like an anaerobic digestion system, where we can apply what they call a CHP model. In terms of the unit itself, it is very robust. It was designed again with that military aspect in mind. Has to be survivable in the field, takes very little maintenance and very little operator intervention. All the units are SCADA monitored, so we're able to see exactly what the unit is doing in the background. That way, if it throws a fault or an alarm, our operators and technicians can get on the phone very quickly and communicate with the operator and able to basically walk them through any kind of remedy that's required. And for the most part, we've always been able to remedy from afar versus having to actually be on site. So there's a tremendous savings there. For us, the whole emphasis was to look at a decentralized model. We are a company who focuses on decentralized facility management. And when it comes to offal and tied to small to medium-sized decentralized meat processors, we found that the meat processors are in a real problematic issue time in terms of, very much as was mentioned before by David, the landfills are not accepting that material. Their rendering plants have all basically pulled back around the larger processors, and there is no other resource available. So it's very easy for us to immediately come onto site, manage all of that offal on site, and then produce a valuable byproduct that of course goes back to community to work as an amendment to soil and avoid the use of commercial fertilizers. Again, for us, one of the topics or the highlights is that we're able to, and which isn't for this discussion particularly, we're able to manage the complete waste stream, which includes all the offal, the blood, hide if necessary, and then of course, all of the wastewater generated at the plant. Water is the next big one on the horizon. We have systems that are identical to the same working principles as our digesters. We're able to deploy modular scalable wastewater treatment units that actually convert to potable water. We have a lot of experience in that area. Again, our largest facility is 148 million gallons a day, raw sewage to potable water. And then the systems go down from there, 760 plants in total. And our whole focus is to de-risk the small producer and basically isolate them from the risks of both offal removal, wastewater treatment back to potable, eliminate 70% of the overall water use within the facility, and provide the cost benefits, obviously, but also the upside benefits to not just the producer, but to the community as a whole. So we're able to provide co-benefits to the community in terms of not using all their water, and then of course producing potable water, which then of course is able to go back to ground or be used within the facility, and of course the offal being converted to a tremendously valuable byproduct that can be used in a commercial sense, either in home gardening straight through to ranching and on-growing of crops. I don't have much time left, but a good example is in Wyoming, producing there. The local ranchers are picking that material up and applying it straight onto the ground and then basically tilling it in, specifically for winter barley, corn, and the like, for their animals at site. Now, with that in mind, the one thing I did forget to mention actually is we are a producer as well. So we actually are an owner operator of an abattoir in Carolina, of all places. And we completely understand from both an owner operator's perspective, as well as the technical innovator side as well, how they must all fit together quite well and provide those co-benefits. We have expanded that, this again, not pertinent per se to the topic, but at the feedlot level, feedlots are also running into a massive problem in terms of animal disposal. Those animals who just naturally die off at site. We're able to deploy the same technology platform in those scenarios and completely eliminate that need to, bury the carcass out in the field somewhere. As well, we're able to treat all wastewater at site. So we're able to eliminate the requirement for lagoons. And again, our whole focus there is to give back both to community while insulating the operator from those external costs and risks that they face. And of course, bring those cost benefits to them, increase herd size, etc., which coincidentally benefits the smaller operators as well, because they're able to then get much healthier animals. They're able to have access to a greater variety in terms of volume from those feedlots who can actually increase volume because they're able to basically de-risk their position. I do have a really quick slide for you if you like, and I can show you. It's this one, I think. I could probably put my glasses on, that would help. There you go. Now, yeah, I think that's, there you go. So again, animals, who we are, I've already explained all of that. Clean, smart, again, the desired results. This is what we're doing in terms of, we're not looking at CO2 issues. We don't have any VOCs that are created from the unit. We're not creating methane or anything naughty like that. And in fact, for us, the key here is that the unit, as I'd mentioned before, is basically autonomous. It just, you load it and it's loaded through automatic source for abilities. And then of course, you have this valuable product that comes out the end without you having to worry about groups having to come pick it up or take it to the landfill, etc. These are some of the advantages. Of course, removes the issues when it comes to the pathogen load. One thing I will add there is that if interesting bugs are present, BSD or something of that nature, and it's detected, you at least have the ability then to segregate that waste stream from the balance of material, test it. You're able to hold it at site because it does not attract vermin or it won't rehydrate. So you're able to then test that material if, for instance, prions are present. That material has been degraded and composted to the point where it actually will be accepted at landfill, because it's not going to cook off in a landfill and cause those other issues. And it can be safely disposed of. So here, just a simple pie chart in terms of what we're able to provide with, of course, eliminating the emissions, the extra trucking, and of course, the risks that are involved. Here's a good example. This is just a 20-yard bin into the digester, shredder, hopper. This is a day hopper, digester, pretty straightforward, pretty shiny output. And this is the final material. Oh, sorry. This is what the material looks like 24 hours later. Can you see that, everybody? Can you guys see that? Yeah, very straightforward, not complicated. Again, some frequently asked questions. This is going to be circulated from what I understand, so you'll see it. This is another example. This is in Carolina, where it's an outflow system by conveyor from the plant. So offal right off the kill floor, straight up, straight into the shredder, into the hopper, out. And then again, just showing you the ability to be able to design units and fit them into pretty tight spaces if necessary. This is another unit. This is in Montana. Again, straight off the kill floor, shredder, hopper, digester, output. Very straightforward. Just some of our clients. So again, it comes down to a matter of being able to isolate the risk that is presented to the abattoirs themselves while increasing their productivity on the floor, because they're not having to put the labor into trying to manage barrels. And, you know, if the guy doesn't decide to come pick the truck up one day and, you know, you're left with all that offal outside, everybody's upset, smells like nasty. So this eliminates all of those issues while providing, as I mentioned before, the upside benefits to both the abattoir itself and of course the community at large, and producing a high grade composted product that can you put to ground immediately. We have the units in schools, as I mentioned before, military, abattoirs, hotels. The units are present in numerous applications outside of just offal and animal waste. And I'll leave it at that. I got 2 minutes left.
I got us started a little bit late with my excessive preamble, Alistair. If you want to take a couple extra minutes and go through some of your FAQ, there's some great questions rolling in, and we'll hold those until the end. But yeah, if you want to talk about any of those frequently asked questions, it look like some interesting things there.
So in terms of, thank you, in terms of what it will manage, the unit will manage, it'll handle basically any offal, which is everything from fish, shellfish, you know, cattle, hog, sheep, fowl, you name it, straight through to wastewater treatment sludge. We use the units in Poland a lot for treating wastewater treatment plant sludge, where we convert it into a dry material and it's then used in a boiler system for centralized heating, which the boiler is very frightening because it was made by the Russians about 1950. So it's kind of a freaky looking thing, but we use it for that. We use it for a lot of manure, actually, at both at the feedlot level, and then of course in, you know, you could use it as sale barn. We also use it for a number of on-site facilities where they're putting sheep and just basically bedding through it and manure. Labor intensive, no. The system's designed to have, as I mentioned, very little operator intervention. It's all SCADA monitored. The operator actually also will receive a message notifying them that there may be a fault or alarm with the unit. And our guys are right there at the same time being able to walk them through that process. Will it produce usable energy as a byproduct, you know, electrical thermal? No, it won't. Again, it is too efficient to produce enough heat to recover. That's too efficient to produce a product that we would then take and burn. Now, in many cases, we have used that. We have a number of applications in schools, oddly enough, that the byproduct is used as a fuel in a boiler system. However, when you look at it in the terms of, do I want to burn it or use it to offset the use of commercial fertilizers and grow food products wins over every time. In terms of does it require a permit? Most jurisdictions, no, it doesn't require a permit at all. In fact, we have full support of the USDA in America, as well as here CFIA in Canada, and of course in the EU. Does it require a vent? Yes, we do have a vent on the system, a stack as it's called, and that's simply to remove some of the steam that's coming off the unit. It's not very visible unless it's Wyoming 22 below, and then you can probably see some steam coming off the system. Does the system require water? No. Discharge water? No. Does it use a lot of energy? Actually, no, it doesn't. We rely on just smart engineering and technology advancements. We use a very small motor. There is 2 motors in the system. One is to drive the main drive, which is quite large. That drive is specifically designed to provide a very high torque value on a frequency drive to be able to drive the paddles, but it's designed to take all of the energy produced by a very small motor and then of course turn it into a tremendous amount of output energy. So we don't use a lot of energy in the unit. Our biggest systems, let's say, you know, for instance, the one in Wyoming, you're doing 5 tons a day. that unit will run around $14 to $18 a day to operate. And that's at 12 cents a kilowatt. The process time, again, is 24 hours. So as I showed you in the previous slide, I'm moving too quick here. That's the final product 24 hours later, and it's ready to go to ground. Excuse me. I got a bit of a cold. So it's, again, no additives. You don't have to pile enzymes in. You don't have to add a whole bunch of crazy things in there. One thing that we do recommend, oddly enough, is rice hull pellets, oddly enough. Now, rice hull pellets we use specifically to provide an additional boost to the output material, even though the output material is probably the best thing you can put to ground. As a matter of fact, there's a number of studies. One was done by EPA and USDA in conjunction with two universities, US universities, on the benefits of putting this material to ground. And in fact, the one study, and it was done through the University of Minnesota, showed a 26% increase in wheat production, oddly enough. By adding a rice hull pellet, you're basically just adding silica. Silica is one of the most depleted products in the soil when you're farming. And of course, silica is the baseline management system when it comes to on-growing plants. Is this a batch or continuous process? It's continuous. You can add waste anytime. Can the finished product be used immediately? Yes. Maintenance, again, very little maintenance required, and we design it that way because, again, following the military pathway, you can't be sending guys in the field in the middle of bloody nowhere. And we have systems as far away as Kwajalein in the Marshall Islands, all the way up north slope of Alaska, a number of them, highest points in the Yukon, Chile, Iceland, they're everywhere. What does the system cost? That's always a tricky question. There's a base cost to the unit itself in the different size ranges, and then other costs come into play if we have to add specifics, for instance, conveyors and the like, and those are additional costs. But again, what we like to do is discover, which I thought was very interesting in your questionnaire earlier, we look to match the budget line. So in other words, when we're asked to look at an opportunity, the first thing we do is work with the group to determine what that cost structure is, what the current cost center is on offal disposal. But we also look at the manpower and the labor costs that are involved. We then assess those, round those up together, present them in a logical fashion to the owner group to be able to say, look, this is what you're paying per month. We're prepared to supply the equipment to you for a less value. In other words, we're looking to basically swap a budget line, not recreate the wheel and have you basically have the owner capitalize another project, which can be extremely expensive. So we don't want to do that. We offer the services, basically a managed services agreement. And simply that means is that we'll place the kit, we'll charge you a nominal fee per month, and we'll manage everything from there. In terms of on-site repair, maintenance, 24-hour call out and the like, we used to have a large roving team. Really all that accomplished was them acquiring and accumulating more air miles than you could ever use in your lifetime. So, and moving those guys around the countryside was very expensive. So what we did is we decided to further follow our decentralized model and discover, recruit local human assets, which are always available, especially in farming communities. There's people there that know how to fix, a 1942 Ferguson tractor when nobody else could if they wanted to, and they could do it at night with a flashlight clenched between their teeth. We recruit those individuals. They're paid to do that maintenance, regular maintenance, as well as the 24-hour call out, because again, we see the unit as mission critical. And again, just examples of the system itself. Yes, that's it for me. I hope that was helpful. Again, we're here to help. If you have any questions, as the same as any of the team, we're here to answer any questions, and we're available pretty much all the time if you have any follow-on questions or would like to walk through any opportunities.
That was fantastic, Alistair. I'm thanks for walking through the FAQ. That answered a lot of my questions. We do have some very good questions that have stacked up in the Q&A box, so we're gonna address after we speak with Matthew. Beau, did you have anything that you wanted to add to this before we move on to our next
No, Alistair, and you did a great job of kind of outlining kind of the obstacles, and then Alistair looking at our solution to this, creating an on-site finished soil amendment is pretty exciting, I think, for a lot of these processors to be able to do that on site. I mean, that's just kind of the beauty of the system. And yeah, one thing that is unique to every processor is the team comes on, designs, they look at kind of their kill floor, what's exiting there, what's coming off the fab and boning, if you have an inedible cooler, and then each system is designed to fit kind of the processor's current system, whether it's a conveyor system, whether it's a tote lift, a number of ways to kind of get the same thing done, but each one is specifically designed, for each processor.
Absolutely right. We've built and operated 36 facilities, processing facilities, from Vietnam to top of Scotland, basically a global level. And we have a lot of experience in terms of fitting things into pretty obscure spaces. One of our fortes was putting basically a 10,000 square foot processing plant into the bowels of a ship, so they're able to process at sea. So we have a lot of experience in being able to basically manage any flow internally in the plant.
Awesome. Okay. Beau, Alistair, that was really fascinating, and I can't wait to learn more about this. We'll make sure at the end of this presentation that I will post my contact info, and anyone who may have joined late or didn't get the first part of our presentation will be able to contact me, and I'll be able to share the slides. This will also be posted. This webinar will be posted to the Niche Meat Processing Assistance Network website, as well as our YouTube channel. So we'll talk about that at the end. But Beau, Alistair, thank you so much. Really, really fascinating stuff. And now we're going to move on to Matthew Epp from Ecodrum.
There we go. Let's unmute myself. So thank you, Alistair, and Beau and David and Rebecca. This is just a fantastic opportunity to talk about composting, because anybody who's in the composting industry, we all know that at the parties, we're not the popular ones, because as soon as people say, hey, what do you do for a living? And you start talking about composting, dead animal parts, usually then they kind of go on to the next person. And it's actually my oldest daughter. That's how I knew she was dating some guy, because we were at the school, and he started talking to me about composting. It took me 60 seconds to go, wait a second, something's funny here. And sure enough, they were interested in each other. We'll leave it at that. But so what I'm going to do today for a little bit is I'm just going to talk about how composting works from a basic level, and then kind of work that into our systems. I appreciated Alistair's presentation, and he included a lot of really good base information. So I'm going to kind of jump off of that. But so what is composting, and what is Ecodrum, and how does it work? So composting in its natural form is a natural biological breakdown of organic materials into stabilized nutrients. That's kind of a summation phrase for it. You're taking what is something that will essentially rot, and you're stabilizing those nutrients into soil enhancers that can be used for plant growth and food production. And now this breakdown at a very basic level happens when 4 main factors are in balance. So first, you have your moistures in balance, you have a carbon nitrogen ratio, and you have oxygen. Alistair referenced the anaerobic and aerobic differences. So to give a 20-second explanation there, anaerobic is a lack of oxygen, and that typically produces your methanes and your greenhouse gases and your bad odors to go with it. When you have enough oxygen, it's an aerobic process, and therefore it produces the less harmful gases and significantly less odors. So that's the four items: moisture, carbon, nitrogen, and oxygen. And when these four things are in balance, microorganisms naturally flourish to convert these raw materials that we're talking about today into a biosecure soil enhancer or compost product, or there's a couple different terms that kind of get floated around. But so an Ecodrum composter turns everyday processing waste, such as animal carcasses, bones, hides, blood, guts, into a usable soil enhancer. So the Ecodrum, even though it's a piece of machinery, we talk about composting as natural and biological. The Ecodrum just controls the environment to reliably accelerate the breakdown process itself to create the soil enhancers. So that's kind of a basic rundown on composting, and I'm not sure the base knowledge of the group here, but so I'm just going to jump over now to a quick slideshow and some of the stuff I just ran through. But now some of you are just a word of note before I bring that up. Some of you aren't going to find composting applicable at all, and that's totally fine. But for some, this is going to be a perfect fit. Typically, we find homes in smaller or remote communities, in companies and facilities that don't want to pay for offsite disposal, or they don't like the transporting aspect of it, or the greenhouse gas, carbon footprints that are associated. We're very energy efficient systems. Our basic composters run on a 20 amp fuse. And we've got sites that in remote areas that have actually run off of solar panels. So they're very environmentally friendly types of systems. Now, Alistair referenced the medium-sized facilities, and then he referenced up to the large ones. I'm going to do the exact opposite and reference the medium-sized and reference down to the smaller processors and communities. But let's see now if I can get this. There we go. This is a little bit of a general presentation plan. Now, most of my pictures here are actual sites. These are what we would refer to as working sites, as opposed to glamour shots. I have one or two glamour shots, you'll notice, because they're pretty shiny and stuff like that. But I prefer to put in actual functioning sites so you can see what it really looks like. But
Hey,
the composting. Oh, yep.
We can't see your slides yet.
Oh, that's no good. Let's see, what did I do wrong here? Oh, standby one. Let's try this again. How's that?
Looking good. Just throw it in presentation mode and we will be all set. Beauty.
Thank you for the heads up. I appreciate that. I would have blown through the whole thing and you guys would have been. All right, so this is what I was referring to. I'm throwing some real pictures up of some compost sites. So we kind of went through some of the basic elements of composting. So I'm just going to reference the pictures here. Alistair did a great job referencing the heat that the microbes produce. And so you'll see some of the steam. Obviously, we don't leave it open like this, but this is just when you open the loading door, this is some shots inside of loading doors and discharged compost. And the heat that's being given off. But the microbes themselves put off a great amount of heat, the thermophilic activity that create the temperatures. So when we accelerate that process through forcing air into it and making sure the process is mixed correctly, you get those temperatures that create the pathogen free compost product. So it's the EPA biosolid protocols. So this is just the CN ratios and the moisture and the oxygen that we referred to. So feeding the microorganisms. In order for the microorganisms, the composting process to occur, we need to create a suitable environment for the microorganisms to live and grow. So in addition to the nitrogen source, which is of course all the dead animal parts, the offal and the inedibles, correct carbon materials need to be present. And Alistair was referring to rice husks, which are a great option. We use everything from wood shavings, dried wood shavings, to peanut shells, to these are ground up corn cobs. So any dry carbon source in a site analysis, a discovery visit, we'll discuss what's available in your area for maximum ease and efficiency in your system. So I don't need to peel through this entire slide, but I noticed in the questionnaire that David put up that there was several of you that do static pile composting. So this is just a little bit of a comparison slide between in-vessel composting versus static pile composting. So we too are a continual feed system. So you'll see in the pictures coming up, as the Ecodrum rotates, it moves the compost as it's doing its thing along inside the drum, creating space for new materials to be added in the loading door. So it's not a pile where once the pile is made, you need to maintain the pile without really adding anything else to it until completion. So again, too, when you're in vessel, this is not going to attract scavengers like your rats or your bears or eagles or whatever's in your area, which would be opposed to a static pile. It's contained, it's biosecure. Now the system itself is automated, so it turns everything automatically, it aerates everything automatically. And the material is broken down typically in a matter of days, but we'll say up to 2 weeks, just to be on the safe side. So that's opposed to static pile. If anybody's ever done static pile composting, a little bit of a trial and error ratio. You don't really know until you flip it. You have to kind of temperature probe it all the time. There's a lot of work that goes into that. It's a little bit of what we call a trial and error process. Material also in static piles takes significantly longer to break down. So when it comes to meat processing facilities, there's several things we need to consider: how many animals are being processed, the location of the site, and the sensitivity to odor control. Now, in this comment itself, a lot of it is just public perception of odor control, how close to your neighbors, kind of a thing. An example of this is we have one site up in Northwest Washington State that there was a government official that lived next door, so there was a lot of caution that was by the facility that was taken to ensure correct odor control. And subsequently, no, the government guy really likes us because there's no smell. But the public often has a perception, as soon as they say composting, of bad odors. So we just have to be sensitive in talking about it to the local community. So also in consideration is what's the end goal. Is this something where you want to create a secondary business where you're selling compost to the general public, or simply for your own land application to grow crops? Often it ends up, most of the time it ends up being for land application. You'll end up with the best crops in the area and people will ask you why, and then you don't tell them, keep it secret. Yeah, so this is a really wordy slide. I would ask you to look at the right-hand sides. This is kind of a typical compost site. So there's several pieces in here, and similar to Alistair and Beau, we'll come and do an assessment. We'll see what kind of designs we can do, but just for illustrative purposes. So some of the options, of course, the core of every compost site is our composters themselves. Then options include a mixer for pre-processing, and I'll show some pictures of this coming up, but a mixer for pre-processing. The mixer provides storage for your dead stock, so you don't need to use your refrigeration or anything like that in the interim. It just comes out of your shop, goes straight into the mixer. It also is a place where you can meter the loading of the system. It creates a very simple daily operating procedure that really minimizes the manpower, the man hours that need to go into waste considerations. Another option is we can do conveyor loading systems and discharge removal systems, so it's truly a hands-off system. We have a bone crusher, so you can crush up the larger bones and skulls. I know beef skulls are presented an issue in the industry, a growing issue. Not quite that hides are, but so it's nice to have a bone crusher. It crushes them up and adds them to the compost. It also adds some very good nutrient value to the compost if you're on the selling or using side. For any of those odor control issues or public perceptions, we have an air exhaust biofilter that we can put on the forced air system. So it's truly an odorless process. We also have temperature data logging. Typically, the younger crowd likes the temperature data logging sitting at home on the couch looking at your phone to see what the temperatures are. It kind of depends what you like to do. So here's just some pictures. So these are the pre-processing. It's just a mixer and a conveyor. If this works, so this is kind of what it looks like. People go and you pre-mix inedibles. It's disgusting. It actually isn't. It creates like a dry hamburger type of material. You can see some of the smaller bones that have been broken up in there. Go. So that will pre-mix it, and then what we would call in the composting industry, your mix goes into the composter hot. So when you pre-mix it like this, you actually start gaining thermophilic activity within a couple hours. And when you put it into a vessel, an aerated vessel, when it's already mixed like this, you get instant high temperatures, and it really accelerates your throughput. So it's just some pictures of the bone crushers. I would say quite evidently, these are pictures of new bone crushers because they don't quite look like this once you start using them. But it's a pretty robust piece of equipment. And so the video on the right is just, now normally you wouldn't put them in one at a time. You would just, you have your hopper on top and you just fill the hopper, and at the end of the day, or whenever you're crushing your bones, you turn it on. So we actually dialed it down. The bone crushers have a clutch system on them. So if they do like bung up, or let's say some wood or something falls in there, it's not going to eat itself. It will sense too much back pressure and back off. This is just a quick one of I can't actually see on my screen. There we go. So there's just some hooves and stuff going through. It's the same thing. We just have the clutch to demonstrate. There it is. So this slide is just to demonstrate. We don't need to read it. It's just to demonstrate that we will come and do a site analysis with you. We want to understand your systems, your processes in your shop, and we look at some shops kill 1 day a week, and then they do cut and wraps the rest of the week. Some shops kill a couple times a week in smaller increments. So we take a look at what your site does. Then we design a compost site with your input. We strive to make a relationship with our clients. We don't want to come in and tell you how to run your shop. We want to learn about you and your shop, and then how we can fit into your process. Then in that process, often there's discoveries as to neighbors that could use this as well. So we kind of like to work in that relationship mindset model. So here's just a couple pictures of the discharge bays. So these obviously don't have the conveyors for the removal process, but these make for better pictures. So as you can see, these are like straight out of into the composter. So this is just material that a few days prior, this one is corn cobs and these two are wood shavings. And then Alistair referred to the 70% reduction in volume. In the composting process itself in vessel, we'll see about a 30% reduction in volume. Then in a subsequent pile, it'll continue to break down and reduce in volume until we've achieved similar volume reductions. So here's some basic pictures of some sheds, just some examples as to what it can look like. We're going to get, now these are just some basic pictures. So this is the larger shed design. So the shop is on the other side of the wall. And here, this is actually a barn facility. So this would be a live production site. Just some similar pictures. So some of the aspects about our company, our international headquarters is in Ozark, Arkansas. That's our main production facility for the Ecodrum. And you're all welcome. If anybody's curious or you want to see this, you can come do a tour of the shop, and then we'll take you to, we've got some research projects at the University of Arkansas, and then we've got customers in the area, so we can do a little tour. So our team, yeah, our maintenance staff is out of there. The majority of our maintenance is done from a distance. If it's a small issue, we'll mail you the parts and video you through, so it's a quicker fix. If it's something that requires on site, well, we have local repair, or we call them mobile mechanics, that'll come out and do those repairs, so they're done quickly and efficiently. So included with every purchase is user training. We're not going to leave you alone until you tell us to, and you're happy and understanding your system. If you need a refresher, we've got online videos, just some basic videos. Most of them are on YouTube. We're pretty open that way. That'll run you through the basics of it. We also have online chat help or phoning. Everybody in our company is compost certified. Through university facilities, extension faculties. So we kind of have a silo of knowledge around composting dead animal parts. So you can call pretty much anybody in our company and get some answers if you can't get if you just call the main lines. But we really do. We strive to help you understand and not just flip the on switch. So we do have compost or comprehensive compost testing. Once it's done, so this compost testing will give you your basic rundowns, including your NPKs and your nutrient analysis of your compost. That is often turns into a business to business opportunity where you can take that analysis, go to local greenhouses or growing facilities and say, hey, are you interested in our compost? And then they just come and take it and use it themselves, or it gives you information for using it on your own fields. Very important here is a fecal coliform. So every site we do pathogen testing, so you have confidence that this is meeting the required standards. So we're a part of, this is just a small slice of federations and stuff all over North America. We're also active overseas. We've got dealers and installations in Israel to Australia to recently we've started putting facilities into the Middle East. So this is a worldwide issue, and we're happy to be on the leading edge. We too are active in research projects. We're currently involved and have been involved in multiple different university research projects in regards to composting, specifically in different types of dead stock materials, so we understand a wider range of it. If you want to hear, you can actually go to YouTube and Google biosecurity, Ecodrum biosecurity video, and there's interviews that the universities have posted online in regards to their thoughts on the biosecurity aspect and some of the research that they've done with the Ecodrum composters. So I'm not sure, I've got a quick video here. David, do you think we have time just for like, I'll slice it up. I won't show the whole thing, but it's just, this is a YouTube video at an abattoir using Ecodrums, and it kind of gives a little bit of an unabashed operator opinion. Now, I'm not sure if the sound will come through though.
Yeah, let's try it out. I think we've got a couple of minutes. We've got some really good questions stacked up that I want to make sure we get to. So yeah, I think if it's fairly short, we could definitely take a look.
Yeah, hang on a second, starting halfway through here, so not sure. Sorry, man, something's going wrong here. Not sure why it's starting out. Hang on, let me try on my screen. There we go.
Yeah, it doesn't seem to be any audio.
No, hey, I'm getting audio on my end. Well, for y'all out there, if you're interested, Google Ecodrum, not Google, sorry, YouTube search Ecodrum Abattoir, and this is free access on YouTube for anybody that wants to watch it.
And if you don't mind sharing, if you have the link for the video and want to share it in the chat, then the audience can pull it up on their browser for after the video, and then I can also include it in the materials as well. So we'll
Sounds good.
Yeah.
When I'm in the slideshow version or a screen like this, I don't have the chat box. Oh yes, I do right there. I'll do it at the end there so I can keep going now. You'll see my concentration face, which isn't very good. So I just wanted to say thanks for giving us the time and the space and allowing to do this. So my name's Matthew. Again, you can reach me at matthew@polycanam.com. So this is our parent company. Ecodrum Composters, plural.com. That's our website. We've got everything on our website, from some basic schematics to pictures to industry breakouts to contact information for various people within our company. So feel absolutely free to reach out to me anytime, or anybody else in the company as well. So I appreciate it.
Thanks, Matthew. Yeah, I want to, before jumping into the Q&A, I just want to encourage everybody to reach out to Beau and Matthew to talk about these solutions. If you have further questions, beyond what we address in the Q&A. I just have recently met both groups, and they have both been fantastic to work with and very approachable. And I know very little about composting and solid waste solutions, and have they've been able to explain these things to me in a way that I've been able to understand. So I highly recommend furthering the conversation with these two groups, because they've been great to work with. So thanks, Matthew. And let's dive into the Q&A. We got some great questions here. So I'm just going to pose these basically to both, and we can kind of start with, we'll just go in the order that we presented. We can start with Beau and Alistair and then move to Matthew, and we'll try to move through these as quickly as we can, just in the interest of time. Beau, Alistair, Matthew, if anybody has to drop off because of timing, I know we're running a little bit later, please just let me know, and I'll stop yammering for a minute and you can go ahead and sign off, but we'll dive into it. Let's see. Okay, first one. We've got a question for Alistair from Jennifer. Has the system been tested with handling deer waste? There seems to be a lot of challenges in Minnesota with deer waste disposal, as most rendering companies won't accept it and landfills don't.
Yeah, absolutely. The whole carcass, as I mentioned, in terms of landfills, not landfills, feedlots, those units are whole carcass units. So the whole carcass of the animal goes in. It doesn't have to be divided up. And these are roadkill animals in terms of deer, or they are culled animals, specifically because of wasting disease and the like. So that animal is processed as with any abattoir waste, and then it comes out as exactly as you saw in the photos. Now, if there is issues in terms of, again, as one of the other questions was posed, you can hold the material, just as Matthew had pointed out with his unit, you can hold the material at site because it won't off gas, it doesn't smell, and of course it won't decompose at site. So if there's any question in terms of any kind of bugs in that material, it could be pulled, tested at a lab, and then if the bugs are not present, of course, could use a compost, but if they are present, it can go to the landfill. And we've checked this out with Colorado, Wyoming, basically all the way up here into British Columbia, wherever there's any kind of issue that there may be wasting disease, which is the most prevalent one, and of course roadkill, or animals that are culled as well. So if the bugs are present, it can go to the landfill because it's already basically all broken down. It's not going to rot in the landfill, and it won't create a leachate issue.
And to add a thought to that, Alistair, applicable to both of us, is because you've achieved that reduction in volume, you're actually taking significantly less material to the landfill. And in that transport process, if you do find that stuff in there, in that transport process, you're not transporting raw dead stock, you're transporting a compost material. So it's significantly cheaper, less trips, and easier to transport.
That doesn't leak all over the place like the other stuff. But
Great. Okay. I'm gonna actually alternate the order in which we do this. So got a couple of good questions from Arian, who's in the NPAN family, one of the founders of NPAN. So hey Arian, good to see you. Starting with Matthew, how do the shredders and crushers do with full beef hides, and will these systems take blood too, or is that too wet?
We pump blood directly from the floor. There's numbers of ways that it's managed. So some have just grates on the floor where it's then pumped out. Some have grates on the floor where it goes to sewer. We just do some modifications there. We either use a catch unit, so that catch unit rolls in underneath the animal when it's bled out. And then of course we pump from there right back into the unit, just through a return system. Adding the blood is absolutely fantastic for the end product, as you can imagine. It is, yeah. And in terms of hides, hides are not an issue. The only issue that you end up with hides is that you have hair. Hair, just like with a 2,000-year-old mummy, for whatever reason, the hair just stays in the body. It's the craziest stuff. So hair will be present. Now it can be also treated because we have a secondary grinder. So it's not a shredder, it's a grinder. And what it does, it just pulverizes the material down and blends it back in. And that includes any kind of remnant little hoof or bone matter. In terms of whole carcasses, as I had mentioned before, we provide the unit with a whole carcass shredder as well. And it's a two-stage shredder. So what it does is it's what they call a pre-breaker, which are just for whole animals, but it doesn't reduce down to -1, and then underneath it has a secondary shredder that reduces down to -1.
Matthew, how about your system?
You betcha. So hides compost well. That's the bottom line. Hides, leather and hides are two very different. One is chemically treated and molecularly altered. Hides are an organic material that'll compost. That's the bottom line. Blood for composting purposes. Very intuitive question on the moisture. Blood compost fine, but if you're going to add the blood, we always do the pre-mixing so that you can ensure you don't have extreme pockets of wet that then take time to mix in. But blood is a massive nutrient boost to an end product compost, and for the composting process itself, the microbes just love it. It's like rocket fuel.
Great. Okay, this one specifically for Matthew. What would you do to accommodate a larger volume, like a 30 head of beef a day plant? And this person references being about 17,000 pounds of waste.
Yeah, so by and large, our systems are modular, both in individual composter length and in composting systems themselves. So the answer to your question is we would grind on, or pre-mix, bone grind, whatever we want to do on the pre-steps, and then it gets conveyor loaded over the top. It's actually quite efficient. Bigger isn't always better. The other side of that is that requires a significantly more conversation and knowledge, intimate knowledge about that particular business. So there would be some conversation that would take place beforehand just to get to understand, is this on site? Is this on the other side of the wall at your plant? Or is this on a different piece of property? What kind of animals are we referring to? What are your flows? What are your high days, your low days? Lots of different questions. So welcome that, throw me an email and we can start a discussion there to see what the fit is. Often too, in larger facilities like that, they have what we would refer to as higher problem ingredients. So there's one or two things such as bones and hides, let's say, that are a trigger to want to make some changes. So sometimes we isolate individual, like let's say the rendering company loves the blood and guts, so they can get that off site for free, but the bones and hides are an issue. So then we'll create sites and systems around your specific.
Great. Okay. Here's an interesting question. I'm sure a lot of people are going to want to know about this one. When fat solids are removed from a wastewater grease trap, are those able to be added to these systems? Alistair, let's start with you.
Yeah, absolutely. As I mentioned before, we have a whole division that deals specifically with wastewater treatment. And one of the big issues that you have in wastewater treatment is what they call fat bergs. So they're just a collection of fat, and especially at rendering or wastewater, or sorry, abattoirs. If it's being pumped to the sewage system from the plant, you'll end up with fatbergs generally in the uplift station located close to the plant. And they become a real problem for everybody concerned. And in that particular case, yes, they're added to the digester, and you can just chuck them in. It takes a couple of people to manhandle it. It's kind of icky, but it can be done.
Matthew, how about you?
Yeah, you bet. Fatbergs. So I think Alistair, my answer would mimic his, so I'll go a little bit beyond that, in that organic material in general will compost. So that's not a problem. In fact, we've taken sludge out of a membrane bioreactor wastewater processing facility, which is designed to remove all the nutrients, and we just added a few more nutrients to it and bam, it composts. So there's if it's organic material, it will compost. So that's the short answer.
Great. Okay. Here's a question. Let's alternate. Let's start with Matthew for this one. How long does the compost stay good or sellable for?
Oh, very good question. So in what we would call a curing or maturing pile, it will stay there virtually indefinitely. We have we do a lot of whole carcass composting, so on-farm mortality. So their main objective, especially now in the last couple of years with AI in the poultry industry, they just don't, their objective isn't actually the creation of compost. Their objective is the elimination of vehicles and materials traveling to and from farm sites. So they literally compost it, dump it in that pile back there, and they leave it there forever. Now, if you dig to the center of those piles, that'll be the richest, blackest earth you've ever found. It's super rich. It'll burn. You have to cut it with other materials, with other soil so it's not quite so hot. But yeah, you can sell it right away as a soil enhancer. A lot of farmers will actually, now we're getting into soil science, but a lot of farmers will actually, the best phrase I heard was pepper your potatoes. They'll spread it on their fields, spring and fall, disc it in, and over the course of a couple of years, they change the complexion of the soil in their fields. The soil it's a lot lighter, a lot less bulk density, not so packed. It holds moisture. It becomes drought resistant because when it rains, it doesn't just run off. It actually penetrates into the soil. Plus, you've got some of the nutrients that aren't used right away. Synthetic fertilizers, as I'm sure you guys have seen too, Alistair and Beau, synthetic fertilizers, they go on, they're either used or they wash off. They don't stay in the soil. They don't positively impact the soil for future growing seasons. There is no cumulative effect of synthetic fertilizers. It's just on and used or on and off. But I'm not sure if that was answering the question, but I keep talking.
Definitely commercial fertilizers are like tires. They're designed to wear away so that you have to buy more of them. It's a great business model. And the same with our product. When the product comes out of the unit, it's generally loaded into 1-ton bulk bags for storage purposes. We don't have to put it out in the ground to mature, but it can go directly to market. We also have material that we still hold now. In fact, I'll whip in the back there in a second and grab a sample and show you that I've had that material now for 5 years and it's still as potent. And the reason I mean potent is that, for fun, when a few years ago, and even as early as April this year, I take a little sample out and then I put it on a plate or a tray. I get my grandson to step in it, and then he walks on the grass. And then, of course, in the morning, you'll see where his footprints are, just to show the potency of it. But it doesn't smell. It smells like coffee grounds, actually, is what it smells like. I've actually written on the jar, the container, this is not coffee, because when I'm away, I'm afraid that they're going to throw it in there and use it. You never know. It might actually taste good. I don't know. But you can also do a tea out of it. Same as with Matthew, for instance. We have a lot of ranchers, farmers, and landscapers that will also create a tea. So they'll mix it with water and then spray it on as a tea product. Yeah.
Interesting. Is everybody got time for 4 more questions?
Absolutely.
Okay, thank you so much. Really appreciate the flexibility. Okay, this one comes from Chris Fuller, one of our technical assistance providers through NMPAN. Good to see you, Chris. Can you speak to the differences, if any, between constant use versus intermittent use, say once a month, for instance? Does the system need cleaning in between? Let's start with you, Alistair.
Yeah, with our system, there's a number of things. If the system, for instance, will set it to specific timelines, pre-programmed, which change the program anytime. If the system senses that it's not being fed, it will hibernate. So it'll go into a sleep, and then it will just basically slow the whole process down, keep everything alive, but it won't just turn off. If the system needs to be shut down, a good example is at a school. No, we don't clean it out. It stays in there. The material, whatever's left, the material stays in the unit. And then when the school comes back online, they just hit go and she starts all over again. So you don't need to clean it out.
How about you, Matthew?
Yeah, for us, a very similar answer. We have we call it an idle mode when nothing's going in. So in its basic core, again, this is if you understand how it works, you understand the why. Microbes don't die when they run out of food; they just go dormant. So you keep them alive by just not starving them of oxygen or drying them totally out. So our system goes into an idle mode, keeps them alive, and you throw things back in, and then it kicks right back up again.
Yep.
We've actually intentionally frozen units solid, like northern Canada climate solid, and then thawed it out and they kick right back on again. So the microbes are it takes some extreme activity to actually kill the microbial activity.
Okay. Let's see. This audience member asks, they say, we do not slaughter. We are simply a processor, so like a value-added processor. Our waste includes bones and inedibles. The inedible meat contains spices and cure in the form of sodium nitrite. Is the cured inedible waste compostable? Let's start with you, Matthew.
In general, one of our slogans is what you put in is what you get out. So the answer to the question is everything will compost fine. And that phrase is actually more associated to the carbon material you put in. If you put in treated wood, you will get the chemicals of the treated wood out. So that's just kind of the example. If you're putting spices and things in, they'll compost and come out the other side, but by and large, it'll compost just fine. All the value-added pieces, like the trimmings and stuff like that, the cured meats and that will break down.
Absolutely, the same answer. I think the downside is that you may have a higher sodium count, which you'll have to be cautious of if you're putting it back to ground. But that's really not going to be a big issue. I think the upside is that it'll smell like jerky, possibly. That'd be really cool.
It does.
Yeah.
Yeah. When it comes to the sodium in the ground, if you're taking that soil amendment to use it as a majority piece in some ground, then it's a problem. But if you're just putting it on a little bit here and there and a little bit here and there, you'll be okay. That's kind of fun.
Okay. Luke Kearns asks, how is it possible for the Assured Renewables unit to only take 24 hours? What is happening to the materials inside that unit?
It really is. It's the thermophilic action. And by example, this is just thermodynamics at its best. The simple answer is kept at 160 and agitated, and as the air is brought into the unit for the bugs to breathe and feed, it will break down in 24 hours. That is how it works. Now, a better example is that if you go to your compost pile and that material that's in the center of the compost pile, if you take a handful of raw material and you get your hand in there, you stick it inside that material where it's warm, it's breaking down the thermophilic action. Make sure you cover the hole back up so heat stays in there. Come back the next morning, it's gone. It will just get eaten alive in there. Like don't leave your hand in there.
Literally.
Yeah.
Okay, great. And so I've got a couple of questions about grants. So would either of these systems qualify for the USDA REAP grant? So that's the renewable energy grant.
Again, ours would. We don't again like to supplement the byproduct, the composted material, as a fuel, given the shortage of fertilizer in the market and the growing concerns around commercial fertilizers. The logic prevails that it should go to feed the populace as a composted biofertilizer, or the numerous terms Matthew pointed out you could use. However, yes, it can be used as a fuel, and yes, we do use it as a fuel. And it goes into a biomass boiler. It's an ORC engine. It's a closed loop system, uses an organic fluid, basically the same kind of premise as your refrigerator. Gas expands, drives a expander, which is like a worm gear. We don't like to use steam because you need steam operator. Worm gear drives the generator produces electricity, and then you get the heat as well. So it's a combined heat power unit. You do have to supplement it because your volume that you would require, unless you're doing 30, 40 head a day, like our facility in Carolina, we just 30 head a day, so that's like 17,000 pounds. That just runs right through the digester. It's coming out, as I had mentioned earlier, around 70% of the input is coming out because it's a lot of trim and the like, hides, etc. That material can be used as a biomass for a boiler unit to create heat or energy. The only downside is, as I mentioned, it's better put to ground to grow the vegetables to feed the people that are going to need to operate the equipment. But it can.
How about you, Matthew? Do you have any experience with the Rural Energy for America program?
You know what, I don't. I'm going to go back to right at the beginning of my presentation when we typically focus, where Alistair focuses on the medium size and up, we focus on the medium size and down. So typically the volumes, once you've achieved that reduction in volume with the composting activity, it's really not worth your time to use it as a fuel source. Now, as far as getting grant money, I've never applied for that, but typically it's just not worth the effort.
Okay, and then I'll ask one last question, and we'll start with Matthew, because I know you've had some back and forth conversation. We originally, we've had a lot of ambiguity, and there's been just a lot of discovery when it comes to the local MCAP grants. Talking about, and this is the new grant for everybody that is listening. I'm sure we're all familiar with it, but it's the newest round of grants through the USDA that talks about supporting the increasing the capacity of local meat processing. And there's two. There's the larger of the two, and then there's the specific equipment only grant. And we've gotten at NMPAN, we've gotten some mixed signals about whether or not composting vessels were considered equipment, or if they could be covered under the MCAP grant. So, I've had some conversations. Matthew, you've had some conversations. I'm sure Alistair, you've heard some things. Let's start with you, Matthew. What have you heard most recently about the MCAP grant? Can this be used as equipment or somehow under that umbrella?
That's a really good question, and the ambiguity that's come out of there is definite. And I do have a meeting in a couple of weeks just to clarify some of I think there's some questions that they had as to how it would fit in, not does it fit in, but how could they fit it in? So what I've heard back is twofold. Primarily on the equipment only, it's kind of a no-brainer. You're buying equipment for the purposes, it works. But under the processing expansion projects of the 1.3.2 in the MCAP, there's a section that reads, under the section that says examples of activities and initiatives that can be funded by this program include but aren't limited to, there's one that says developing, customizing, or installing equipment that reduces greenhouse gas emissions, increases efficiency in water use, improves air and water quality, and or meets one or more of the USDA's climate action goals. So it's a different application, right? And we're well versed in this one. But when you compare composting on site compared to hauling off site, tremendous greenhouse gas differences. In fact, it's a glaring, I'd rather do this application because it's kind of one of those no-brainers. As far as meeting the USDA's climate action goals, some of the audience might know of the Equip Fund program with the USDA and the NRCS, the Environmental Quality Improvement Program. That's for whole carcass. It's not applicable here, but we are pre-approved. We're stand nationally on the pre-approved list and have for over 10 years. So we definitely meet the USDA's climate action goals and can fit in there. And in the grant fund itself, I'll end here. In the grant fund itself, there is a website link to those climate action goals. So it's nice to say there's climate action goals, but what are they? So there's a hot link in the application form to those goals.
Alistair, have you learned anything different or have any additional information about the newest round of grants?
No, our experience is basically the same. Like most government grants, they're, ambiguous is a loose term to use when it comes to the government. We've been very successful in terms of working with the government. For instance, all the units have load scales. They measure inputs, outputs. We're able to immediately collate those to demonstrate, for the owner's benefit to translate back to community, as well as to use for sales purposes to end users of the impact that they are stopping on the climate, which also includes everything from, and we not just collate the load at the site, we then factor in on a quarterly basis and surmise in a year what the road transport removal impact on landfill being freed up space. The list just goes on the tax base, etc. And then of course, what those CO2 emissions or greenhouse gas emissions would look like. And in that sense, yes, they adhere directly to what the USDA is looking for, EPA, everybody else A's, lots of A's in there. And then of course, at the granting level, working with the government, on the equipment side, it's a no-brainer. You're able to increase production, you're able to better manage facilities, labor costs, etc., to increase your production just by installing this type of equipment. And then of course, demonstrating to them the thoroughness and the third party side of it, because all of the registration on our side is done by a third party and it comes with the kit. So as I say, on a quarter and an annualized basis, that you get a certified report, which is what the EPA USDA is looking for, somebody to say, okay, this is actually factual. You guys aren't just making it up. So it's just about being creative with the government and kind of showing them the pathway to what they think they want to see, which is generally they don't really have an end game clue.
I'd really like to highlight that, what you just said, like the bottom line. I get a lot of questions about, and I have been in this position as well, where people are asking about grants and they say the language is ambiguous, and I don't want to waste my time applying for the grant because if it doesn't say exactly that it is this or this or this or what it is not, then I may not get the grant. Well, yeah. The language of the grant is meant to be that way to a degree because they want you to create the narrative right. And prove how you're going to spend the money. I mean, if someone is going, if we go and ask someone for money, they want to know how you're going to spend it, right? And so they want the narrative to explain why it fits the criteria. So the ambiguity is somewhat purposeful. And I do want to draw a little bit of attention to what Rebecca just put in the chat box. The local MCAP grants are one of our best opportunities to fund alternative waste systems such as these. I hope processors jump on this opportunity now. I don't think there will be many other small grants for this sector such as this one. And that's probably true. This is an opportunity that hasn't come up before, and it is pretty inclusive when it comes to waste, water, and solid waste solutions. And while there are a lot of other equipment that we probably would like to be spending, this is we haven't seen something like this before, and we don't anticipate seeing it again anytime soon. So we do hope that people jump on this opportunity as you're thinking about how to spend your grant funds.
Absolutely, and that's actually a very good point in terms of government. They in many cases, you're right, they purposely write it because they want you to be creative, and rather than them dictate to you, basically the one path, or the two paths that you must take. They want you to be creative. They want you to come back and say, look, this is how we're going to manage our particular scenario, because it might not be the same as Joe down the road. And that, of course, causes creativity and encourages some innovation on both the producer's side as well as government side. And as I mentioned, with just a little bit of thought, and especially if you're able to use the tools that are available to you in terms of mapping and collating data and collecting that data, you actually have a fighting chance. And you'll find that the government literally will step up and quite happily help out, because you provided the answer that they're looking for in many cases. And they can be very proactive, in fact, and to be truthful, they do want to give the money away because they want people to be successful, and they want to look like they're doing their job or doing their job.
And often what I'll tell people is, if you have a local person or someone you're talking to, ask them what they want to hear. Don't be afraid to say, hey, what are you guys actually looking for in the application process? You'd be shocked. Sometimes they'll give you the answer. All right, we are looking for this. I had one, where was that? Actually, it's in BC, Alistair, in the fisheries. It was the most confusing application, kept getting reworked back. And finally just said, what are you looking for? And they just said, we are looking for the number of tons of carbon reduction per year.
Yep.
So it was one sentence email, instant approval.
Yep.
So if it's too ambiguous, don't be afraid to ask the question, hey, what exactly are you looking for? You'd be surprised what you can get.
Absolutely.
Okay, great. Well, we're gonna wrap up here. And as we do, I just want to remind everyone in the audience, please, if you have questions about funding and grant opportunities, and you want to know how to get started, or you'd like some feedback or some coaching or some assistance, please reach out to the Flower Hill Institute, who is the organizing group for the MPPTA Meat and Poultry Processing Technical Assistance Program that NMPAN, American Association of Meat Processors, American Meat Science Association, the Agricultural Utilization Research Institute, and the Intertribal Agriculture Council we're all banded together to provide technical assistance for writing your grant. So if you go to Flower Hill Institute's website, you can fill out their MPPTA request form, and they will link you with a technical assistance provider that can provide you with the information that you need based on your questions. And the calls are free. This is a grant opportunity through the Agricultural Marketing Service, the USDA, and these people's time are paid for already. So please utilize them. Please book these calls to get linked up with grants so that you can look into potentially obtaining some of these solutions. Matthew, Beau, Alistair, this has been awesome. I've learned so much today. I can't tell you how many times I wish I would have had a solution like this in the plants that I have managed over the years. It just would have been a complete game changer. When I was in California managing a butchery out there, we were paying $1,500 twice a week to haul out our slaughter viscera and processing inedible to a line landfill, and it was crippling to our business. That's our bottom line. So I can't thank you enough for coming on here.
The same one, David, the same one that we've spoken about, is $2,400 a day right now. He's paying.
I believe it. That's
a Lamborghini.
So yeah, thank you fellas so much. So again, I'm David Darling, Program Manager for NPAN. There's our website, nichemeatprocessing.org. There's my email. Please use it. If you have questions that we didn't get to, or that if you'd like to know more, drop me a line. I'm happy to answer those. What we're going to do is we're going to take this recording and we're going to post it to our YouTube channel, but you're also going to be able to go on to that website that I've got listed right there and scroll halfway down the page to where it says webinars and events. You'll be able to click on that and you will see this webinar archived there so that you can dip in. And I'm also hoping to get the slide presentations from Alistair and Matthew to include on that page so that you can have those materials to look at and read it at your own leisure. And those also contain Alistair, Beau, and Matthew's contact information. So thanks everybody for joining. That was fantastic. Yeah, can't wait to work with everybody in the future.
Thank you.
Thank you very much for having this.
Of course,
Thanks for the opportunity.
Happy summer.
Thanks, everybody. Cheers, Matthew.
Cheers, Alistair. See you soon.
See you
Thanks again.
soon. See everybody.